All right, in this video, we're going to discuss closures and scope in JavaScript. Okay, so in JavaScript, a closure is a function used to limit the scope of access of identifiers such as variables and function names within that scope. Okay, so basically the way you create a closure is just to create a function. All right, here's a really simple example. We have a function set a. All this does is declare a variable and set it equal to some value, some string value. Now outside of the function, we're going to console.log this value a. Very clearly, we have not executed this function, so this is not even going to be defined in any way, right? So let's run this. We're going to run node closures and scope. Okay, and we do get an error, so that's good. Well, what if we were to run this function? Okay, so what we can do is we can run these functions in a manner that's called self-executing. So we can basically do the exact same thing and have a self-executing function. And the way we define one of these, this is just the function, and we put little parentheses around it. So basically JavaScript evaluates this to a function, and we could do a lot of things with this. We could do, store it in a variable, let f equal, right? And basically we've seen this before. This evaluates to a function that's stored in memory, and we have a reference to that item f, just like that. This is sort of the same thing, except we're putting parentheses around it. So JavaScript evaluates this, and then once it evaluates to a function, we still directly have a reference to it in code here, and so we can just call left and right parentheses, and it executes. And also you could pass in some variables here, arg, and then param, right? So parameter is the variable of the function, and we'd be passing in the argument data that gets stored in the parameter, right? That's a possibility too. So you'll see these are self-executing functions, but the idea here, whereas above we did not have this function execute, so there's really no chance of this let even occurring, but we did log it out anyway, and we saw that we did not have access to that variable a. Now we're running the function, so should we have access to this or not? So the answer is no, because this is a closure. All right, so a is still not defined. Okay, and we even see this here. A is not defined. So the idea of a closure is it closes access to the variables defined inside of it. So a function closes off access to the outside world of anything defined inside of it. Now that access can leak out, which we'll get into in a little bit, if you have a function down here. If I had some function in here that referenced a and run the function in the outer scope, the function where it was defined would still have access to this inner scope a. Okay, so well after this function executes, as long as there's external access to something inside somehow, then that scope is maintained. All right, so this is pretty core to JavaScript. I know that might be a little confusing to start with, but we'll explain it a little further and go into more detail. Okay, so for now, functions create closures, or basically their own scope, and then you can have self-executing functions. And in older code bases, you'll see this sort of style for all of the JavaScript files. In some code bases will look like this, where they put all of their code in this function, self-executing function, and that's to avoid letting the variable scope leak out into a global context. All right, so speaking of a global context, all right, let's take a look at some code here. All right, I need to comment this out so we don't get the error. All right, so the global object in Node is global. All right, while in the browser, the global object is called window. So generally speaking, you write code for Node, or you write it for the browser, but sometimes it does make sense to write code that can be used in both places, and that can be a little bit tricky if you don't know exactly which place your code is running, and you need to access the global variable. One way to do it is something like this, something as easy as a try catch. All right, so if I want to create this variable global, and I don't care if it's window or global. In most cases you would, but not all cases. You could do something like this. So we define a variable GBL, and we try to set the window variable. In Node, we're going to get an error here because we try to reference a variable that does not exist. All right, and so that's going to cause an error. So we'll go into this catch block, and then we'll say global equals GBL equals global. Now we already declared the variable up here, so we are not declaring it inside of here. Since we declared it in the outside scope here, we have it's going to be set to this variable. Now what can we do here? So first, let's just take a look at what this variable is. We can do something like console.dir GBL, and what's on it. Okay, so we can take a peek in here. And it's going to be different in the browser. This is, notice Node kind of prints out the contents of the object, but it doesn't print out everything. In the browser, you can explore objects a little bit nicer with console.dir. There are little arrows where you can click and expand out other objects and things like that. So here, for example, we have, this is an object mapping. Here's an object. You could open and close these things and explore them further if you wanted to in the browser. And also in the browser, there are many, many, many more variables and DOM-related functions and variables and things like that. So the DOM is the document object model. So it has everything to do with rendering a web page, right? And so JavaScript has to access all the elements on the DOM, all these different things. So there's a big portion of functionality that is in browser JavaScript that's not in server-side JavaScript. Similarly, with Node, we're using server-side JavaScript. There's a big portion of functionality that's not available in the browser. For example, in Node, we can access files, we can open files and write files and do different things like that. Obviously, you don't want that in the browser, because if that occurred in the browser, we are actually downloading the JavaScript from some site we don't know. We've never read the code. So we don't want to just download some code and have somebody be able to open files on our computer, right? So it has to be sandboxed. So these are two different environments. All right. So that shows some of the functions in there. You should be familiar with some of these: set timeout, set interval, clear timeout, clear interval. There's also math.random. This isn't showing everything. Again, Node kind of just prints out some of the object. All right. So, but the idea here is you do have access to this global object. All right. So let's create a variable, and this is going to be agnostic of scope. All right, so we have our global, and we say .a, and so we just set it some value. This is agnostic global scope, any context, so it can be Node.js or the browser. And we can run global.a, and we should get a value. Right? Agnostic global scope. We also see that the math object is there. So that's on every global instance. And you can reference anything that's on the global object by itself. Okay. So if I have a reference in JavaScript to an identifier that I haven't defined, JavaScript moves up one level in the scope chain and looks for it there. If it doesn't find it there, it keeps moving up the scope chain until finally it's on the global scope. And then in this case, math is defined on the global scope, and so it does return an object. Right? So here's the math object, and we can use that either from global.math, which you might see window.math, or you might see global.math, or just math. Either way, but we do have access to that object and all of the functions on that object. So math.random, for example. Okay, so that's sort of the global object. Now, why we're going to dive into why this global object is important. Because of this scoping, right? The way, if I have an identifier, JavaScript tries to look in the current scope for it. If it can't find it, it goes up and it keeps going up until it reaches the global scope. If it's not on the global scope, then you get an error, right? You get an exception raised. Okay. So because of this, you want to be careful about where you define things. There's something called global scope pollution. So we don't want to add too many things to this global variable. Almost nothing, right? So here you would never want to do something like this where we just create a variable a and do something like this. I'm just showcasing functionality here. The reason being is in large projects, you have lots of different files, lots of different constructors, lots of different functions, all sorts of different things going on. And if you put too much on this global object, maybe another developer is using global.a. Maybe another developer is using global.b. And if you're both using it, who's to say who was the last one to set it and who changed it to what and how things will go. The program could behave in ways that you're not expecting, right? So in general, it's a bad practice to modify the global scope, except in very, very limited ways, okay? And definitely you don't want to overwrite anything that already exists on the global scope. For example, like create an object called math, right? Because that's built in. All right. So there's a mode that helps prevent some errors like this of modifying the global context. Okay, so there's something called strict mode. So this prevents certain bad practices that can lead to bugs and errors. This is used by default in newer JavaScript modules and when you define classes. You can define strict mode in just certain functions or just certain files by adding a declaration at the very top of the file. It's just a string value called use strict, right? Semicolon. Now notice this is meant to be backwards compatible with older systems that don't implement strict mode, and that's why it's just a string definition. It's not even stored in a variable, because other JavaScript engines, older ones, will just read this as a string that never gets assigned and move on, right? Newer JavaScript, and this directive is at this point somewhat old, but that's why it's just a string value, right? It's for backwards compatibility, and most of the time if you're using newer modules you won't even use this. It'll be enabled by default. But what it does, and this is important to understanding how JavaScript works, here we can define a variable x equals 3. All right, we did not use a declaration. We didn't use the older var syntax. We didn't use the newer let or const. Okay, so this is not allowed in strict mode, but it is if we do not have strict mode on. So I'm going to comment out that strict mode declaration, and we're going to see x equals 3 is now going to be set on the global scope. So if I didn't declare this variable to exist in my current scope, the assumption is JavaScript keeps going up scope looking for this x that has not been defined, and if it can't find it, it gets to the global scope and says, okay, we'll just put it on the global scope. Okay, so JavaScript was designed to basically not complain and do as much as possible, but this can cause all kinds of strange behaviors. So this is sort of considered a bad part of JavaScript, which is why we have the strict mode. All right, so here's what happens. This gets added to our global.x, all right? And then this works in Node only. So this is how you exit a script. So process.exit, and you pass in the exit code. All right, so this does not work in a browser. This is just to kind of exit real quickly. I wanted to mention that. Okay, so we run this, and sure enough, global.x gives us the value of 3. All right, and then we exit. And we could, Node might not show it, but we can look on the dir, and we can see if it shows up there. There it is. Okay, so we do see A and X have both been attached to the global object. And again, this is bad. This is called global namespace pollution, right? We don't want to pollute the global object. Okay, let me comment out this process.exit. Okay, so let's enable strict mode real quick. So if we uncomment this, and again, this can be used at the top of a file, or when you create a function, you can have it as like the first line of the function, use strict. Okay, and you'll see this especially in older code bases. With the newer module systems, you generally won't see this as much, but just so you know what it is. All right. Okay, so now with use strict, if you do not declare your variables, this is an error, right? And that's so you don't pollute the global namespace. Now you can still specifically do something like this, but you're being deliberate about it. You're saying, I know it's probably a bad practice to pollute the global namespace, but I'm going to go ahead and do it anyway. And I know what I'm doing because I'm typing out the global first. Okay, so this is allowed in strict mode, while discouraged, this is disallowed. All right, so we can go, I guess I can go ahead and add use strict back in here too. Use, not user. And again, it's just a string literal with a semicolon at the end. All right, and I know I use semicolons because that was the standard. That was the way I learned. As you get more advanced, there are many cases where you don't need semicolons, and a lot of people don't use them. I just tend to use them because I'm used to it. But there are still some certain places where you need semicolons, and so if you never use them, that can be a little bit confusing. So that's another reason why I use them. But in professional programming, you would just have to get with your team and decide, are you using them or not, that sort of thing. All right, next we want to talk about the scoping of the this keyword. All right, so let's take a look here. The this keyword has inconsistent behavior depending on the way you are executing your JavaScript. So in general, it can be accessed with this, but in some contexts that will be a global scope, or in others undefined, right? So this, it's basically just, we've talked about using this inside of functions primarily, right? But when you don't use this inside of a function, depending on the way you're running your JavaScript, that is to say, are you running it in a server environment like Node.js? Are you running it in the browser, different versions, etc.? Is it strict mode? These sort of things can all change the behavior of what this means when it's not inside of a function or inside of a constructor or something like that. All right, so we can start and we can just kind of explore what this is right now. So this scope outside of a function is inconsistent. All right, so we're going to just look at what it is here in Node. And so in this case, this just references an empty object. Okay, and so if we want to call this our module, or we want to call this something like that, we can attach objects to it. So I could say this.a, or I already stored this in mod, so I can say mod.a, and I could still attach plenty of objects to it, or properties, right? And sure enough, we can add these items in here. All right, now that's different than the file scope, and that's different than the global scope. All right, so we can console.dir global GBL, and then A should still be, yeah, so A is still the global context of A is the agnostic global scope. All right, so this in the particular case where we're running now is just kind of an empty object. It's sort of like a module scope or a file scope, but it's inconsistent. So in general, you just kind of want to avoid using this if it's not inside of a function or something like that. All right. Now, what we can do is we can create a closure. So we talked at the beginning about a closure just basically seals off variables and identifiers from an outer scope. All right, so it creates an inner scope. So this is going to tie into the this scope and then the global scope here in a second. So we have self-executing function. So one way to create a closure that runs immediately, right? So we talked about that. We create this function. We have parentheses around the function definition, right? That basically just evaluates this function, and then we immediately call it. All right. So this is a closure scope. So everything that runs is executed in here is executing inside of this inner scope. Now the closure scope does have access to the outer scope, but not the other way around. The outer scope does not have access to the inner scope. The inner scope has to grant the outer scope access by setting a variable like a global variable or something. The inner scope would have access to our GBL variable because we defined it outside, right? Let GBL, this is outer scope. So our inner scope would have access to that, and it could set GBL dot something, right? But that's the only way the outer scope can have access. The inner scope is sealed off unless the inner scope explicitly grants access to the outer scope. All right, so here we are going to log A. Now notice we didn't define A in this closure, so that means we have access to A from outside. Right? Now, is this A going to be here? Is this going to be that value, or is it going to be on the global scope, because we have one of those as well? Right? So we're gonna try that, and then here this is something in the closure scope. All right. So if we defined a B earlier, let's create some A's and B's here. I left this off. We need to let A equal file scope, let B equal file scope in lowercase letters. Okay, and so console log A and B, and then console log this. And we'll comment this up for a second. Okay, so just defining two variables basically, file scope, and then A is the value A. So that's the this scope. Right, we already went over that. So now back to our self-executing function. We're going to log out A, which should be file scope, right? Because the inner scope has access to the outer scope, and then let B is the closure scope. And so B, now we're setting it equal to something. So this is an entirely different variable than this. Even though the identifier name is the same, the way these variables are tracked, they are tracked depending on their scope. So the outer scope has a B variable, and then the inner scope has a B variable as well that's different. It's entirely different. It's a different memory location, right? And so once we have declared a variable inside of the function scope, then that variable, the function scope is going to, anytime we reference that variable name, it's going to be the function scope version, right? Here we did not declare it, so it's going to be the outer scope version. Okay, so sure enough, A was the file scope, and then B was closure scope. Now here is where it gets interesting. What's going to happen when we run outside the function? So is we never set A inside the function, so A should probably still be this, but what is B going to be? So we declared B inside of the function scope, and this B should reference that one, but now we're outside, so this is proving that we do not have access to the inside of this function scope, right? This B is going to reference that B out there. Okay, and we're back to file scope. And here's a little explanation of everything that's going on there. Okay, so variable B is defined in the file scope prior to running the closure. And then since a new different variable B was declared inside the closure scope, right, those two variables are tracked distinctly, even though they have the same name. Okay, like I said, the way JavaScript actually stores the variable information is all based on scope. So you have scope and then a list of identifiers in that scope. It's not that much different than an object, where you have an object and a list of properties, and one of those properties can have a value that's an object and a list of properties, and one of those properties can have an object that has a list of properties, right? So you have nested scope. All right, so after the closure variable B declaration, the closure variable is created and used in all places inside the closure from then on. The file scope variable B is no longer accessible using the variable reference B. Okay, so file scope variable no longer becomes referenceable after you have declared an identifier of the same name inside the scope. Once JavaScript exits the closure, the previous scope is accessible, meaning B will be a reference to whatever it did before the closure was executed, right? Basically because it's an entirely different and distinct variable. Okay, now in older code bases, you might see the var keyword. Try to avoid that. It has some behaviors that will be a little bit unusual to you, and it does something, there's something called variable hoisting. So wherever you declare the variable with var, it gets moved to the top, and so you get some strange behaviors that you might not expect. So I wanted to demonstrate one reason why we're going to use let pretty much exclusively. When you get more advanced, you'll use const for certain things. You'll use it a lot actually, but for simplicity, we'll mostly just use let. So we want to use the newer let declaration as opposed to the older var because let isolates your variable scope better. So here's an example in a for loop, right? So we have on the outer scope, we're defining a variable 4,444. But then here we're defining a variable, but this is inside of a for loop scope. Now, in old JavaScript, this is not its own scope, right? So it's not its own closure. A function creates a closure. Now, that's one of the reasons they introduced this new way to declare variables. So for things like this, let, when you declare a variable in a for loop, that let is limited to the for loop, right? And we're going to see, we're going to log out. This is going to go from 0 to 2, right? So 0 and 1, and print those out. And we want to see what I is after the fact, right? So if I is limited to this scope, I, when we print it out down here, should be 444. Okay, and it is. Now, the alternative would be to use var. All right, and let's take a look at what that is. Same exact layout, but we're using the var keyword instead. Now, this does some interesting things like variable hoisting. So anytime you have a variable declaration, it actually moves it to the very top of the file. And then when you redeclare it, if it's already been declared, it's using the same thing because this is not in its own closure. All right, so these two J's are the same, whereas with let, they're not. So this is why we always want to use let. So here we go, J equals 4,444. Same thing, J equals 0. Going to be 0, 1. And we print out J. Well, because these two J's are the same, they share a scope, this last value is just going to be 1. Or it actually adds one more to it, right? So this is the way the for loop works. J is 0. Run the loop, or you have the value, the initial declaration. This is run at the very beginning of the for loop. Then before the body of the code is checked, you have the condition. Is J less than 2? If so, we run the condition. At the end of the code block, you execute this code every time. So then we add 1, right? So then at the beginning, we check, is 1 less than 2? Yes. So we print out 1, and then at the end, we add 1. Is 2 less than 2? No. And so we print out, and J is in fact 2. So that is an important thing to remember too, that this value actually does increment one more time before the last condition is checked. Okay. And then one last thing with scoping, what we might want to do, we talked a little bit about it. If I want to grant access from my inner scope to an outer scope, okay, this is common in older code bases. So I have some outer scope, or this might even be the global object. I might have a file that creates a function constructor or something like that, a class, and I want to grant access to the outer scope somehow. So we have some object here. I'm going to just call it outer scope, right? And then here is our closure. So we're just defining the function again, self-executing, right? And then we're defining with let a variable in here. Now here is where I'm defining a function, but I'm defining it on the outer scope object. So this is an example of the inner scope leaking out to the outer scope, but this is intentional. Okay, so here we're defining a function on this outer scope variable, and then we are granting this access to this inner scope variable, right? So now as I run this function, this self-executing closure here, the function I created will always still have access to this variable inside. All right, and so since that's attached to the outer scope, this foo variable is accessible in that way. It's read-only, right? I can't set this variable from inside unless I made a function to do that, right? I could make an outer scope.set and pass in a value here and then change this variable. But right now the way it's set up is I have one function and it can read the values. All right, so here we have let foo equal uppercase foo, and the idea here is what's going to be printed to the terminal when we run outer scope dot function. Is this function, this reference to foo in the function, is that going to reference this foo or this foo? Okay, it's the lowercase version. So this is very interesting with JavaScript. This allows you to seal off certain variables from the outer scope, but then you can also grant them back in controlled ways. So this is kind of a mechanism that you can, this was historically how you sort of made private variables in classes in JavaScript before you actually had classes. You had constructor functions, you had objects. So these would be private variables because the outer scope can't access them, but you can provide access through controlled mechanisms like a read function or a set function or something like that. All right, so that's really important to know in JavaScript because scoping and closures are a really huge part of it, and it can be really confusing too. So knowing that going forward will help you understand most JavaScript code that you're kind of looking at, which variable is which, and you know how is this value being stored, how's it being referenced, etc. Okay, so that's good enough for closures and scope. We're going to move on next time to using closures to create sort of an older style object with a constructor function, and then do the same thing with a class, and you can kind of see the differences in syntax. All right, that's it for today.